Hello everyone. We are going to talk about ultralight client. It's the next step of LAC, Light Ethereum Client. My name is Boris Petrov, Eugene Danilenko, and we are from Status Research Team. I'm going to great thanks to Solfi Soldi, Frank, Jacek, and Jared for helping us, supporting us, and for reviewing and doing some code. And we're going to talk about status story. We start from working with Infura and less. Next step is the beta with working with Infura. And the next step is ultralight client. We are going to deliver it in next month. The other step is shared shy client on Nimbus teams. Thanks for Nimbus team and Jacek. So let's start from LEC. It's a big step in Ethereum world. LEC helps to run Ethereum node in each computer. You can run light client on mobile devices. It's very heavy for mobile devices, but you can do it. It's the most popular type of Ethereum node. We work. We can do with light client really decentralized application. You don't need anything. You can use other subservices of Ethereum like Whisper, Swarm, or something else. You can use your own service. But it have several problems, like I have long sync. It's a bad user experience. It takes 5 minutes, something like that. But it have very nice pros. You have nice latest Ethereum API. You have really decentralized application. You can use LEC with your own private network, but things last long. It consumes a lot of resources like network consumption, disk consumption. Chain validation have a lot of battery and CPU consumption. The next step is Infura. It's a very simple solution which allows to use proxy between your client and Ethereum nodes. But I have some problem. There are Fairman service layer. It's kind of caching layer between client and Ethereum nodes. It has some problems because caching is not a good solution for this. You could get different state if you your request processed on different Ethereum nodes and could cache. So you can simply use it by setting up and get a specific URL for Ethereum RPC. We used LEC and Infura instance application at the same time, but Infura has some problems. Some API is not available, like new filters, new payment introduction, and etc. Infura covers 60% of Ethereum API, but after some hacks, allows us to use Infura in stats application. It has great bones. There are no battery consumption. It's minimum traffic, only on just in time. There are no sync. I couldn't start using Infura very fast. It's very simple solution, but its centralization, it's have one point of failure. For example, Russia blocked a lot of API 2 months ago. For example, Infura was blocked with Telegram, and we had to use Infura using VPN. So, as I said, Infura can have inconsistent state and it have less and less API support. if you want to use Infura for private network, you have to create your own Infura because no private network supporting Infura.
Okay, I'll continue. Another one solution is to own your own RPC server. It's possible, but if you want to have a reliable solution, you have to have quite a few nodes, maybe 3 or 5. You have to start using some kind of load balancing, and it really looks like quite cost by time and money solution. Yeah, you will have any API you want in your application or Ethereum service. You can use any private network you want, and you can easily change network you are using now. But in status, we was searching for better solution, and we think that it is ULC, ultralight client. The main idea is quite simple. We just want to make quite well-known LES, light service, better than it is today. One of the main issues of light service is about validation of new blocks. The main idea of ULS, light ultralight client, is to not to do any validation on client side at all. We just want to have an trusted service. We want to connect to them and get new blocks. Then we are checking are all these announcements are the same. If any of them are the same, we can consider to trust it. That's it. We just need to check M hashes and we can go for the next block. So we do some work on client side, but I think it's minimum as possible. Few words about trusted nodes. It can be an issue in it can be a secure issue that we adding new feature like trusted nodes. But it's quite simple, and I think it's secure feature. Trusted nodes can be any type of Ethereum nodes in the network. It can be full node or light node. User can change them by own decision in any time. Moreover, servers that have been chosen like trusted don't receive any more information than untrusted. So it's impossible to distinguish trusted server from untrusted. The trustness is all of trustness is on client side. Our results. First of all, this feature is almost complete, and we've done a pull request to Ethereum code base, and we are waiting for code review. So we have some results, and I think they are great. We still have some cons from left side. It's network and disk space consumption, but we do have some ideas how to make these things better and better. The pros are we have on client side on mobile device latest and quite nice Ethereum API with all the features that we want, like filters, pending transaction filters, and other. We have simple state, and this state is not distributed, so we won't have a bunch of issues from Infura. We can use ULC with our own private networks or any type of test networks that we want. And one of the most important that ULC is difficult to block by third parties. Here it is, a demonstration of sync process on the left is less, on the right is ULC. As you can see, one block is one block on the left side takes around 2.5 seconds, and ULC takes 0.3 seconds. It's almost 8 times faster, and it's finished. Just now, the sync process was finished by ULC, and it takes around 20 seconds to sync from the previous state to current. Here's some links where you can check the current status of ULC feature on status side and Ethereum. As I said before, this feature is quite ready to use on mobile devices and any kind of devices that have limited resources like CPU, memory, and other. What? What? This?
Yes, thank you.
You're welcome. Okay. And we do have some ideas how to make this feature even more better for mobile and better devices. First of all, we should move from static list of trusted nodes to dynamically selected trusted nodes according to some kind of statistics. We are thinking about it, we have some ideas, but we didn't check it right now. We want to check different consensus algorithms, not only N of M, and check what can be better. One of the most valuable feature, we want to calculate CHT roots on less side, less server side, and announce them to clients to make sync process as short as possible. The Salt has already done a pull request to Ethereum code base a month before, and we are waiting for code review and testing this feature. Is this feature is working fine? I think it can make sync process in 5 or 10 seconds maximum. One of the thing is quick tips how to choose a proper solution for your distributed application or service. If you don't need all APIs and you want to keep your application as simple as possible, use Infura. It's good, well-tested solution. It's the most popular in the decentralized world at the moment. If you want more APIs and availability is not an issue for you, you can try and use your own RPC node. Good luck. If you need a reliable, secure, and fast enough solution, and you can try to spend some more traffic than Infura, I think you definitely should try ULC. Maybe this is a solution for you. And last but not least, if you have enough resources, use less. Just use less. Ethereum works quite well. It's well tested, and it has well-known issues that you can help with. That's all. Any questions?
Thank you very much. If you have time, can you
explain what CHT is? Because I just started looking at the light clients, and I would just interested to know, just shortly explain what CHT is.
Really short. It is the thing that makes possible, it's some kind of checkpoint from where you can sync to the current state. It makes possible to not to sync all the history. In short.
Yeah, so have you considered some alternative approaches? Like today during the Zero Knowledge Proofs talk, there was an awesome idea to use Zero Knowledge Proofs to prove the chain tip for light clients.
Yes, we was thinking about different approaches, but they think that we want simple solution. We already have light Ethereum servers and it works. And we are thinking about that we can improve it and see maybe it works quite good enough. For further steps, we do have a research team that are researching for new client on Nimbus. Maybe the approach with Zero Knowledge Proof will work, but we want to improve user experience on current state, on current application. And we want to deliver this feature in this month, in this week maybe, but not in the next year. So.
So one thing that might be much simpler to implement than a succinct knowledge proof is a layer 2 proof of stake scheme. So basically the idea is that people can stake, like either ETH or SNT or whatever, and they, someone that has a staked deposit that's locked up for some period of time can basically publish a signed message that says, at this particular block height, the block hash is this value, and then that message can be put into the blockchain, and it will destroy their deposit on any chain where they submit a value that's incorrect. So, and on any chain where the value is correct, it would reward them some small amount. So the idea basically is that you get some crypto economic assurance that says, this hash actually is the hash of this particular block height, or someone burned a bunch of money trying to trick the client.
Yeah, it's possible.
The question is, who is going to pay the... The question to Vitalik is, who is going to pay to the people who put the deposit?
Actually, the next picture that we are going to work is service model and micropayments on Ethereum. So, yeah.
Yeah, indeed, right. Like, if you have a service model attached to this, you can incentivize people to provide the so-called trusted service. And then this is an excellent way of penalizing these people if they're out of line.
Any questions?
Okay, so my question is like, how do you get access to the proofs of those CHTs then? Because like you're still trusting the other server, the dynamic server, to provide them to you eventually. Otherwise, you still have to generate it all. Or
Yeah,
like I'm talking about this trusted service model now.
We all trust the CHT at the moment. Its value is hard-coded in Ethereum code.
Okay. So, but like, yeah, the point is, at some point, you still have to rely on someone. That's what I was like asking, and it sounds like it's still like that.
Yeah.
Yeah.
At the moment, we trust CHT from Ethereum code base. Yeah, we trust it.
Okay, that's it. Thank you.
Thank you very much. Yeah. Oh, it's so question.
So have you thought at all what this looks like from a UI perspective? So in Status at the moment, you can currently select a mail server, for instance, of your choice. Do you imagine all of this stuff happening programmatically behind the scenes, where like you just sort of are probabilistically routed to a trusted server and nobody knows what that server is, or do you actively select it yourself in Status?
If you are talking about, I think we can start with trusted, with a list of trusted nodes from status cluster, and I think the first feature that we will develop is to move from static list to dynamic list. Okay? Thank you.